Hey guys, Greg here with Brinster Productions, and today we're going to go over an in-depth explanation of crossovers. We're going to go over why you should use them, how the controls work, and what they can do to improve your sound quality. And so this video was in response to a comment we got on one of our other videos on my biggest video publication that I have on our channel is Audio 101 for Live Sound. It's a 4-video set. It's all one big project. It's about 2.5 hours long, and I go over all the basic components of a mid-sized PA system if you're wanting to upgrade from like powered speakers or a powered mixer with speakers on speaker stands. I go over all the components kind of needed for a basic full-size system or a mid-size system for up to a few thousand square foot rooms, several thousand square foot rooms, and even on up to a system you could use for hotel ballrooms. So I go over all the different types of components of subs and tops and rack gear that you need, and different amplifiers and things. So in that process and that signal chain was a crossover, and I kind of briefly touched on it and explained what it was, and somebody was wanting to learn a little more about crossover, so I decided to shoot this video to give you a more in-depth look into what crossovers are. So this is a Ashley crossover, and they come in a couple different varieties. You have 2-way, 3-way, 4-way, and even 5-way crossovers. This one is a 4-channel crossover, so you have independent channels you can work with. And this one does 2-way or 3-way mono. So I have them in stereo 2-way, and what that does is for each incoming signal, so for channel 1 I'm sending my left, it is going to have a low and a high output in 2-way mode, and I'm sending my right side into channel 3, because this crossover I got it used dirt cheap actually for I believe, what did I pay for it? About 90 bucks, because the channel 2 and 4 do not work properly on this one. They're stuck in a higher crossover mode, and I'll talk about what that is in a second. And so this originally was like $500 when these were first came out back in the day. They're discontinued now. So 2 channels work. That's all I'm needing, because I'm just doing the left-right, so it works just fine for me using channel 1 and channel 3, and I have it in 2-way mode. And so what crossovers do, and why you need them, is crossovers will do just that. They cross over frequencies. So they set a crossover point in a signal of where it will divide your outputs to go to say a high and a low, or a top speaker and then a subwoofer. So the actual frequency is where it's adjusting between those two outputs, and that's what a crossover is, or a crossover frequency. So why you need crossovers: this is kind of the one piece of gear you can add into your system to dramatically improve the sound quality, just by plugging one in and dialing in a quick setting. There's not a whole lot of pieces of equipment that can dramatically improve your sound quality like that. The reason why is what a crossover will do for your signal quality is it allows each speaker to work with a very specific range of frequencies in the frequency spectrum. So traditionally, if you just have a full range system, so say you just have, without subs, if you just have a top and a horn, like a 12 and a horn or 15 and a horn, just a single, any type of PA speaker, and you'd have a left and a right. So those you just send out a full range signal. So it comes out of your mixer to, traditionally you'd have a 31 band, and then you would just go to an amplifier and send that whole signal to that whole speaker. And the next upgrade from that is to add a sub to get that nice powerful low range, so you can feel that kick drum and feel those bass guitars. That would be the next upgrade. So what I see sometimes people doing wrong is they just run that entire full range signal to both the top and the sub, They can't figure out why they can't get a nice crystal clear sound quality. And the reason why is because they're sending the same full range signal to both their top and their sub. So a lot of times this will give you kind of a muddy, kind of mushy sound, not so clear and crisp, because the subs are not meant to handle those high frequency ranges. And the tops, once you add subs, don't need to reproduce those frequency ranges. So what the crossover is doing is it is letting each set of speakers work with the best frequencies it can handle. So yes, a full range speaker can usually handle down to about 45-50 hertz if it's a 12 or a 15. But when you add subwoofers, it doesn't need to. So general crossover setting, which we'll go over that in a second, say we'll go with 80 hertz. So at 80 hertz, the subwoofers are taking over and handling everything down all the way down to 20 hertz, or however low the driver can go. Sometimes it's only about actually 25 or 30 hertz is what the speakers can reproduce. And then from 80 on up, your top is taking over. So what this does is it opens up a lot more room for that speaker to work, because it is only working with a narrow frequency range in the spectrum of the traditional 20 to 20 hertz that humans can hear. So it takes work off the speaker not having to reproduce other frequencies when there's another driver to take care of that work for you. So this is kind of the same setup as you'd see in like your hi-fi home stereo systems, where you might have your main left and right speakers that have 3 or 4 different drivers in them. Each one of those drivers is handling a very specific frequency range. So that speaker only has to concentrate on that range, and it can reproduce those better than if it had to do the entire frequency spectrum. So basically, just opening up that range is going to dramatically improve the quality of your sound. So hopefully that explains everything about why you need a crossover and what they do. And so now we'll kind of go over the controls of what you would traditionally see on a crossover. So as I said in this, this one does 2-way and 3-way. There's multiple types of crossovers. You can have 2-way, 3-way, 4-way, and 5-way. And basically, so 2-way is usually a high and a low. A 3-way traditionally would be like a high and a mid, and then a mid and low, and then on up. And it just divides up between a high and high mid, low, low mid, low. Kind of like your EQ on your board. Think of it that way. Your biggest systems usually are a 4-way system. If you're working with a professional line array cabinet, speakers are usually a horn, or sometimes they actually have regular tweeters in them. So you have a high, you have a mid, you have a low, and then you have the 4th is the sub. I've only seen 5-way very seldom, and it would usually be some sort of extra mid driver in between there somewhere, like a low mid, then a low. So it might be a high, a mid, a low mid, a low, and then a sub. But traditionally, for just starting out, you're probably just going to have a high and a low. You're going to have a top speaker, could be a single 15 and a horn, or a dual 15 and a horn, maybe a single 12 and a horn, or whatever you have, and then a subwoofer, a single 18, a dual 18, whichever. So the crossover is going to be working with a high and a low output. So this one, usually the high, or the input's usually on the left side. The Ashleys do this kind of backwards. So we'll start with the input. So the first one's this input level, same as you would have on any other piece of gear. You can have an input level. Traditionally, to keep your unity gain structure, most people just have it set at unity, and you can start with it there, unless you need to turn down some signal on your gain structure or turn up. Then that's why they give you an adjustable control. But most PA systems and professional PA systems, this is set at 0. Then you have the actual crossover frequency. So this is where all that work is taking place. This is the frequency that you select to send where that crossover is between the high and the low. And so usually they will have if it can change from a 2-way to a 3-way or on up, it'll have a range. And so this one is just doing high and low. So I have it in its divided by 10, or its lower range. So if you look here on these numbers, if I can get it to focus, you can see this. It's kind of hard. Is this one goes from its normal setting is 400 to 8K, and then it has it divided by 10, 40 to 800. So 400 to 8K is if I was using this to cross over, let's say if I had a horn. So if I had a three-way system that I had a high, a mid, and a low, I'd be using this control to adjust between those, the mids and the highs, or the low and the high, than if I had a sub. So if I have a high, a low, and a sub. So I don't need 400 to 8K because that range isn't going to help me with the setup with a high top and a sub. So I need 40 to 800. So you need to make sure if yours has a range button or whatever mode you're in, read the manual and figure out so you make sure you're in the right range to divide between a top and a sub. And so I have 40 to 800 is what mine is in. So the reason these other two channels don't work is because the crossover frequency on these, on the channels 2 and 4 on mine, are broke, is they're stuck in the high range. So the frequency filter only works from 400 to 8K on these guys. So that's not usable for me because I'm using it for a top and a sub. So those channels are worthless to me. But channels 1 and 3 work just fine, and like I said, I got it for like $100, so it's definitely worth it to have an Ashley crossover because I just need the two channels. So we're going to skip this response. Yours probably won't have it unless you have a higher end. Basically what this does, I'll just briefly touch on it. It's a pretty complicated system to get into. Response is just how that crossover frequency works. It's not the slope of the frequency, and that can be confusing how it has like this. It shows the little wave here where it's kind of slipping down, slipping over, and then they cross over each other over here. It's not actually changing the slope of the frequency. That's usually set. What this is doing is adding or subtracting dB at that crossover point. So traditionally, if you measure with an RTA, a real-time analyzer that has an SPL reference, the crossover frequency traditionally should see a plus 3 dB at that frequency. So if my system is set at 80 hertz, if I mute my subs, I should have a reference of what 80 hertz is in SPL, and then vice versa, mute the tops and see where it is at the subs. When you combine both of those together, you should only see a plus 3 dB boost at the crossover point, and that's what the manual for the Ashley says is at 6 is a standard. It notches out, so it should have that 3 dB. What this does is it allows you to adjust because not all speakers are as accurate. Sometimes there's imperfections in the way the speaker itself works. So if you have a higher, for some reason, maybe that speaker is more sensitive at that frequency range for where your crossover is, it kind of works. Basically what it's doing is adding dB to that crossover point or subtracting dB from that crossover point. So the Ashley manual says to start with it at 6 to get that normal notch out to compensate. So it should be about 3 dB. And if you turn it to the left or to the bigger numbers, it goes down to 12. Is it supposed to make your system more flat so it's cutting out more dB at that crossover point? So 6 is its general setting, and if you needed to go add dB at the crossover point for something funky going on, then it allows you to turn it up. And read your manual if you have a response to make sure you fully understand what that does. But a lot of crossovers don't even have a response. So then last year you're going to have your output, individual outputs. So as I said, you're going to have a high and a low. Or if you're doing a low, mid, and a high, you're going to have output volumes. And so what this does is you have controls for a high output, so you have a unity setting, and then you have a low output, and then you have a unity, and then plus or minus on that. So this can be used to tune your system out. Traditionally, tops usually sound louder than your subs because all those high frequencies come through sharper, and so they sound louder to us as humans. And so to set this by the meter is you would start with both of them at unity, and you would play pink noise is the easiest way to do this, and use an SPL meter. You can just get one from Radio Shack for like I believe maybe $100, I think, is like their good analog one, or you can get the apps for your phone. And so you just measure the SPL with the tops muted and just run the subs, and then vice versa, and make sure you have the same SPL coming out for both of them. So you would adjust accordingly to balance out your system. So if one is, so you set it with the meter first, and then you just kind of do the rest by ear. If the tops still sound like they're completely overpowering, so for mine, I found that my system, even though I have a more powerful amp on my subs than my top, the highs and stuff still just cut through. I can turn mine back to about -4, and that seems to work with my system. So check it first with SPL meter, and then dial it in by ear from the rest of the way, just to see, you know, so it sounds nice and balanced and flat. So use all the tools you can, you know, using your dB meters or an RTA, and then you can get your system to where it's balanced, so your tops don't overpower your subs, your subs don't overpower your tops. So you want a nice balanced system. So that's why they give you controls for adjusting those individual inputs and outputs. And then you have a mute button, which is handy. You don't have to turn the amp on and off when setting this, as you can just pop in the mutes for that channel. Okay, so that's pretty much what all the controls do. So now we'll go over how to actually work with them and set that signal. So what we'll do is we're going to start with a crossover point all the way down, and we're going to mute my subs, and we're going to play some signal through and just listen to the tops with a crossover all the way down. Okay, so now we have some music playing back, and what we're going to do is we're just going to listen to one side, so I can do this one-handed. So right now I have the crossover point turned all the way down, and I have the subs muted. So this is all the way down at 40 Hertz. So that's actually about the bottom of what most speakers will handle. It would probably sound a little lower if I didn't have the crossover in the signal chain at all, but just to show you what this is doing. So right now you hear that top is getting a lot of the low end, the kick drum, the bass guitar. So we're going to bring it up, and just to make this really drastic, see what the crossover does. So we'll put it up closer. So you heard what that was doing. So that's cutting out frequencies above wherever you set that, or excuse me, below where you set it. So as you turn it up to its higher, so that's up to 800 Hertz. It's cutting out everything below that, sloping off. So obviously I don't need it that high, but just to show you what the control does. We're going to go around 80. So right now my top is getting everything above 80 Hertz. It's sloping off at 80. So now we'll listen to this with the sub. And so just you can hear this. We'll just turn that up. Normally I wouldn't have it like that, but I don't want to run back and forth to the mixer. So to listen to that, this obviously you don't want going to your subs. So if you're sending full range signal to both, you'd get something like this. Now you can hear vocals and guitars in the subs. You definitely don't want all that going to your subs. So it just doesn't sound pretty coming out of a sub. An 18-inch driver is not meant to reproduce those frequencies that well. So we'll bring that back to around 80. And we'll turn the system back to normal here. Unmute the top. So now I have sub and the top. Crossover at 80, so the top's getting everything above 80, the sub is taking 80 below, and I've cleared up room in the system to reproduce each frequency better. Okay, so just for contrast to show you a different crossover. This is a Behringer crossover. This one is the Super X Pro model CX3400. I believe this is their highest analog crossover before they get to like their digital drive rack crossover. So this one is a 2, 3, or 4-way 2-channel. So you can only have 2 incoming channels into this, which is these 2 separate sections here. And it can do 2-way, 3-way, or 4-way. You can do 2-way and 3-way and stereo, to where it's doing 2-way or 3-way on one channel, 2-way and 3-way on the second, or you could do mono 4-way, and it combines both channels into an entire 4-way system. And so it gives little graphs up here for each one. So if you can see here, it says high output, and then over here is the low output right here. And then if you are to go up to a different like the 4-way, it shows over here you have a low, low, mid, and then you have low, mid, and high mid, and that's your 2 selectable crossover points. Then you have the low output, and then you have a low mid output, and then it uses this channel over here for a high mid / high crossover frequency, high mid output, and a high output. So up to a 4-way system, that would be if you had a high, a mid, a low, and a sub output. It would be something like that. So you have a high output, mid output, a low, and then your what's labeled as low mid would actually be your low, and then you have low output, which would be your sub. So that'd be if you had like a line array system, something that has you need each individual amplifiers for a system like that. You need a sub amp, a low amp, a mid amp, and a high amp. So that's how the multi-amp systems work like that, tri-amping and bi-amping. That gets a little more complicated if you're just starting out, but this one could do that. And you would need one for each left and for the right if you had a system. But most of the time, if you got a system that complex, you're probably not going to be using a regular like Behringer crossover. You'd be using like a drive rack system, which you could use Behringer gear. They have a digital drive rack, or DBX as a drive rack system that is a digital device that allows you to have different output levels and set limiters and things like that for each individual output. So those are pretty cool. So they work with a pretty advanced system, is to get the DBX drive racks, or Behringer has a system similar to that, where you can have 1 or 2 or 3, I believe they go up to 3 inputs, and then they're like 4 outs, or 8 out or 6 out, and you can do sub and low, mid and high, stuff like that, and you can set individual levels on those outputs and limiters and compression, and you can even put EQ on the outputs. So you can get a lot more customizable system with a drive rack system. But for just a basic system, a 31 band and a crossover will do you wonders and improving your quality of your sound. So this pretty much covers everything with crossovers. If you have any questions, ask in the comments below. If you'd like to see any other videos done by Brinster Productions, check out our page first and see everything we have on there. We've got about 23, 24 videos on there. If there's something you'd like to see gone over, send us a message and just ask us to do a video over it, and we'll try to find time to throw something together to show you more information about what you're looking for. So thanks for checking out this video, and check out our page. For how-to videos, project ideas, and tricks of the trade, check out the Brinster Productions channel on YouTube. Real production advice from working professionals in the sound and lighting industry.